Okay. Hi, everybody. So I'm very happy to have this workshop with you and share my Mqtt extension with everybody to showcase how this we can use Snap for a real life case and in a production situation. I'm Nizar Ayed, and I'm the manager of upgrade-code.org. It's a coding school here that I have created in Metz in France, near Luxembourg, not far from Luxembourg. And I work mainly with kids from 5 to 18 years old, but the coding school that I have created was, many people invited me to coach and to teach, to train adults to make them understand what is programming and even continue furthermore to learn about web development, coding in general, and become developers. So, among my activities, I I organize coding camps during holidays or in regular days with kids. When I say kids, they are mainly teenagers. And one of the camps was sponsored by a company that asked me to create what they call the Smart Gnome. It's a kind of an IoT, it's a connected object that would be planted with other plants to supervise the watering and the moisture of the soil, the temperature and the environment while being connected to a server and monitored by mobile clients. So this sponsorship helped me with some teenagers create in 15 hours this Smart Gnome, and it was really made feasible thanks to this Snap programming environment and the Mqtt extension that I have created some months before. So I would like to share with you this Mqtt extension and how it was used to make in a few time, very little time, make different teams collaborate together by using the simulation and the emulation of the different components of the IoT environment that we put in place in order to make this project work. So as you have understood, we have the connected object, we have the mobile application, which is the client, and we have also the server in which all the devices are monitored remotely. So do you have any question at that point, or can I continue? Okay, if there is no question, you can stop me at any time if you have any question to understand better what I'm saying. Please forgive me for my English. I don't practice it all the day, so I need some little practice to come back to my regular English as I used it before. So I'm sharing with you now a whiteboard on my iPad, and I will explain very quickly what we will go through today in 1 hour. So we will first start by going through this extension. Sorry, my pen is not working. Oh. Why it is not working? I will create a new one. I'm sorry, it is not working. I don't know why. Okay, never mind. I will continue orally. So I will start by explaining how this Mqtt extension works and how we can send back and forth, publish and subscribe on message topics, and how we can receive them. Afterwards, I will explain a real life case by putting in place a device that is connected to a server and to a client and making them to communicate all together. Okay. So let's go. I will share my screen. Up. Let's go. So I think everybody now is looking to my Snap screen. we will go to the Snap forum first, where I have published my the link to my extension. So if you can go all together, if you would like to download this extension, you are welcome to do it. So it's in the SnapCon 2020 category. And we scroll down to the workshop. Where is it? Oh, yes, it's workshop Mqtt topic, I think. It's, yes, Mqtt extension. Have you found it? Okay, so I have here in my comments, I have put the link for the extension, so you can download it, and then we will import it to Snap. Once it is imported, we will find the main blocks under sensing. So if you scroll down, we have here the different required blocks, and we will start building our first device. So first, when the green flag is clicked, we load the MQTT JavaScript, remote JavaScript. And then we need to create now our client. So we'll put it with big C. And this client, we will set it to there's a new client, and then we will have here the broker. We need to choose one. So I have put some addresses. They don't work all of them. They are not working all of them because they were supposed to be test brokers, but I have found some issues to making them work. But I have my own broker, which is Codimio MQTT. And since we are connected over HTTPS, so we have here, I advise to use the WSS, WebSocket secured WebSocket. And we need here options to connect it to this broker. I have created a guest account. I have disallowed the anonymous connection so that I can track who is connecting and how much and how far. So here we need to put a kind of a JSON. Okay. From a list of the different properties. So the first, we have two.
Nizar, just a quick note. Would you be able to go to that tab for the MQTT extension and copy that link into chat?
Okay.
Yeah.
If they click here on the arrow, they will find it here very quickly. You see?
I see.
With the arrow, they can find it if they click on the WSS.
Would you be able to go into the Snap forum tab? The Snap forum.
Ah, Snap forum. Okay, I will copy it. I understand. Okay,
Thank
that's what you are talking about, the extension itself.
Thank you very much.
Okay, I will put it with the chat. How can I go to the chat here? 30 seconds. Conversation. Okay. So here is the link. Okay. Now I'm back. So I will wait until you download it. Is the block size correct? I mean, is it visible on your screens?
Everything looks okay with me.
Okay, thank you.
Yeah, if anyone is having trouble, you can right-click and save as. It should save as an XML document, and that's correct.
Okay. So I will continue. So here it's very simple to, we put a variable name, which is the client, and then we have here, we create a new MQTT client for this broker that can be selected using the arrow here. So we have Codemio MQTT WSS, and we will create a JSON with this list of properties. So we have the username, which is MQTT-test. And then the password is the same. Okay, and once the client is created, now we can go through I mean, we will connect it. So we have in the sensing blocks here, we have what is required to connect it. But before connecting it that way, I would like to create two costumes. One with the red color. So that means it's not connected, it's offline. Okay, I will rename it to costume off. Then I will duplicate it and rename it to on, then change the color to green. So edit, and we have here, we will select a dark green. Here we are. After that, we start with the costume off. Okay. So we load and we create. Okay, so as we see here, we have the variable that is checked, so we don't need it for now. The point, what we would like, what we will do now is when we click on our sprite, okay, we will switch it on. So we will test if our client is connected or not. So we have here a block in the sensing blocks where we can see if the client is connected. So we need to put the variable client here. And then if it is connected, if it is not connected, so if it is not connected, we will make the connection. And if it is connected, we will end the connection. So we have another block here in the sensing. That means end our MQTT client. And of course, here we will manage now the events. So when we connect, we will broadcast a message to complete the connection and explain the behavior for each event. So here we will put the message, we send the message connect. And then when we receive the message connect, how can I move this? Yes, up, I'm sorry. Okay, I will put it here for now. So when we receive connect, now if you go back to the sensing blocks, we have a C-shaped block, and we will explain the different events. So for the MQTT, we have the event connect. So for your information, you can find many, all the explanations here we have in the GitHub. mqtt.js. And when we click on it, there is a complete documentation. So on the first repository, of course. So if you scroll down, we have here all the events that we can program. So here we have the event connect, reconnect, close, disconnect, offline, error, and message. Okay, so we can do all of them. But we start here when we connect. The first thing we can do is switch the costume to make it on first. Okay, and after that, so we will see it. We'll see after later. And when it is disconnected, and hopefully for the MQTT that I'm using on my broker, it's MQTT 3.1, which is an old one. And when the client is disconnected, there is no more event that can be captured. So that's why we will handle the switch, the costume off. We will handle it directly here. Okay. We will not handle it in the event disconnect. So we'll duplicate it, and just to show you that I will keep it empty. It exists, but it is not handled, and hopefully with my broker. So this is the first thing that can be done. And after that, we will now let's see if all of this disconnection works. Okay. So first we start with the green flag, so that our client is completely initialized with a new client. And then I will click here and it's switched on. And we can see that the event connect was correctly handled because we switched to the costume on. So everything seems to be going well for now. If I click second time, then here the client is not connected. So I mean, the client is connected. So we end the connection and the costume was switched off. So the connection is working well. I hope that it is the same for all of you. Now let's go further and let's handle the other events, and the most important one, which is the message event. So let's go back to sensing and okay, I will duplicate the one existing here, maybe quicker. So on the client message, when he receives a message, many things can happen. Yes, but before receiving a message, we should subscribe to a topic. So, this subscription is done when the client is connected. So here we have the block subscribe, and we will subscribe our client to a hello topic, just an introduction topic. Okay. And then when we receive the message, we need to handle the three elements of a message, which is the topic, the message in itself, and the complete payload. Okay. So I'm sorry, but my screen here, I don't know how to hide. Yes, I think that, oh yes, it's better that way. Now, for the message here, we will create new variables. The first one is the topic. The second one is the message. And the third one is the payload. Okay. All of them, for the event message, we have argument 1, 2, and 3. I will rename them here by using big T here. That means the topic. The M here for the message, and here for the P as a payload. And then we will see on the screen what is the result each time. So the payload, I will put it aside because it will be a table. Okay. Now let's set everything. First thing, we have the topic here, which is set to the big T. I'm sorry. So I will duplicate this and duplicate it a second time. The message here to M. Sorry. And here we need to change, of course, we need to select payload. Okay. Are there questions or everything is going well? Okay, because I'm hearing some sounds. Okay, let's now publish a message on the topic hello. So for this, we have in the sensing, we have the publish block. I will keep it free, not connected to any other block. And I will send hello world, of course, on the topic hello for our client, big client here. And let's see what will happen. So I need to click one time on my red dot so that my client is connected now. And of course, when it is connected, we switch the costume on and we subscribe to the topic hello. If we are not subscribed, we will not receive any message. So now, since we are publishing a message on the topic hello, we should trigger this message event and fill down all those variables. Let's give it a try and see what happens. So as a result here on the scene, I make it bigger. We have the message, it's hello world. The topic is hello. And here the payload seems to be, it's an object. It's a JavaScript object. So what we can do in order to explicitly seed its content, one good thing would be to listify. So I have created a block in the operators, which is listify. And what we will listify is the JavaScript string. So I will call a function. Okay. So let's call the function with the payload, and then I will return the P. Let me check. String. Okay. So since my P variable is a string, so I will JSON.stringify P. And I will call it with this P variable here, or argument, sorry. Then put it in the listify here. Okay, I will put everything correctly here so that we can see what happens. Now let's give it a try again, and then let's publish again. Payload is still an object. Of course, I see. It hasn't worked because we need to reload the different events when we are connected. So here we need to disconnect first and then reconnect back again, you see? So as you see it, we have the payload has changed. I will publish again. Then you see the payload is now a table. And we have some interesting information. We have the command that was received. Is it to retain or not? So those are features that are specific to the MQTT protocol, whether the messages should be retained on the broker or not, and they are linked to the quality of service required. So on my broker, I manage only the quality of service level 0 or 1, not the level 2. And so I can manage the fact that if I retain my messages on the broker and consume them later on or not. Okay, so I have other information about the topic, and also here we have the payload in itself, which is a duplicate. We have a buffer here. So the actual payload, it's the data, and this buffer is those different numbers, which are the characters of my word, which is testing. Somebody is sending other messages, so I'm getting your messages in real life time. So it shows that it works remotely. I'm not tricking you, so that's fine. Okay, thank you very much. Now, just one point why this buffer thing is very, very important, because in real life applications, generally the IoT objects and the connected objects send binary information much more than strings and heavy payloads. So that's why it's important to understand that MQTT was made for lightweight payloads. Okay, so if you have any question to understand further, don't hesitate, please. Now we have this payload, so we will get rid of the payload. It's not very, very important for us, for our application now. It's important for real life cases, of course, but for now, for us, it's not important. So what time is it now? Okay, I will go speed a little bit. Now let's get furthermore and see how interactive I can make my MQTT object. So what I would like to do now is giving some commands to my object. So I will make him receive events and receive, from its environment. Since here I'm working with this snap, I have my keyboard, so I can send events to my object, and I will here handle the keys, up arrows, for example, the up arrow. And when I click on, when I hit the button, the up arrow, I will publish a message that is up on so here I will choose a topic, a special topic. So in order to not to get polluted with your code, direct remote code, so I will create a special variable that I will call it client ID. And then I will initialize this client ID when I start to a random number. So I will join my name with the random number that I will pick it from 1 to, let's say, 110 million. Okay, so that it will be unique. And when I will publish here, I will subscribe to the client to hello, and I will join it to my client ID. So hello client ID. Okay, and again when I publish, I will publish to this topic. That way, I will ensure that it is unique, and I will not interfere with your code, your own code. Okay. Of course, the same for you. So let's go further now. I will just test everything. So I will stop my connected object. I will restart again by hitting, I will reload again from the beginning by hitting the green flag, so that my client ID is quite initialized. Okay. And then I will connect my connected object, and I will publish hi again. So if you publish, if you follow my coding now, I will not interfere with your code. So this is a protection that I can do because I gave a specific ID to my connected object, which is also among the real life specificities of connected objects. Now, when I hit the up arrow, I should receive the message up, and I will see it here. Okay, let's test it. And then up was sent, and everything is good. I will duplicate this to handle the other arrows. So we have 4 arrows generally. Up, down, Duplicate again. Okay, and I will change. We have here right and left. Okay. Now we have down. We have right. I'm sorry. And we have the left. Okay, let's see if all those messages are well handled. Right, up, left, down, everything is good. Very nice. Now, since I have managed the publishing, now let's manage the receiving, because I have subscribed to this topic. So I can, those same messages that I'm sending, I can receive them. Even if it is the same object, never mind, we can see that if I duplicate this screen, I mean, if I save my project and then create another screen, you will see that it will work with no problem. And you have, I think that you have saw it yourself, the messages were completely interchanged between you and me with no problem. But now let's create a new variable that I will call it got message. And then I will initialize this got message first at the beginning. Got message. I will initialize it to false at first. I'm trying to have some room for my code. And when I receive a message, of course, my got message will be changed to true. That will allow me to handle separately when I receive a message. So I will use the hat block when I got message. Then I will, of course, I will switch off the got message at that moment, so that I don't forget it later. Okay, and now let's handle the different cases. If my message was up, I will ask my object to go upward by 10 pixels, for example. So for that, I need to have the if block and test my message. And you will see that we will have a little issue here, and we will investigate why. So if my message is equal to up, sorry, I will duplicate it 4 times. And then I will put here down, right, and left. Each time I will ask my object to change for the up and down to change the Y, and the right and left to change the X by 10 pixels each time. So here, when I go down, I will change my Y -10, and when I go left, change my X by -10 too. Okay, and so now you will see that here I will have an issue, and I will show you. I will hit the button up. You see here that my message was well sent, and it was also well received. I mean, I have received the message up in this topic, but my green dot here hasn't moved as I expected it. Why? In fact, if you get to look on the message itself, it is not, it's a buffer. As I showed you before, it's a set of numbers, and I mean, in the below this M bubble, we do not have the string up. We have something else. So that's why we need to convert this M into an actual string. So how can we see it? So I need to use here the same thing that I have done here. So we'll call it JavaScript, in which I will send the M. And I will just put here return the M dot to string, because it's a buffer again. So this buffer will be converted to a string. And I will change, instead of the P here, I will put the M here. And let's hope that it will work, that I haven't made any mistake. Everything should be reloaded back again. So I will disconnect my object, click again on the red flag, green flag, sorry, and then connect again my object. Okay, and let's try now with the up and down arrows, and you see now it worked very well, and my connected object is working. Okay, again, I repeat, of course, this demo is I'm using a single instance of my connected object, but I could have separated the program into two different parts. One part that is handling the publishing of my arrows, publishing of the messages when I hit the different keys, and a second object that will receive and execute the commands that were received through the broker. So this will work with no problem. Okay, so until I think that here I have reached my goal and showed you how we can implement a client using this MQTT and making communication through remote broker using this messaging system. One remark is that I repeat what I've said before. The messages are not retained on the server, so it's not a variable-based message. Okay, but it's a notification-based messaging, and this MQTT feature is mostly used nowadays with the instant messaging programs like Facebook Messenger, for example. It's completely built on this MQTT thing. When you receive a notification on your mobile, it's an MQTT notification that contains the last message received, and all the history of the messages are synchronized with your local database, and it's not fetched directly from their server. So this MQTT strategy allowed them to download, to decrease the load on their servers. So now I have finished this part of the presentation, and let's go to, okay, my whiteboard is working again. So if you have any question, please ask it now before I go further by showing you a real life case where we can build a system in which we can emulate or simulate the different parts of an IoT platform. The different parts are, we have the devices, the server, and the clients. But do you have any question until now? Okay, it seems that there are no questions. So I will go with the presentation of my life case. So in case anyone missed the link, download this. Okay, Samita, thank you. I will stop sharing my screen, and then I will share my whiteboard. Okay, it's coming. Okay. Now, as I said, an IoT platform will be compound of a device, okay, which is a set of sensors. That's, for example, sensor for temperature, for humidity, okay? And this device is connected to a server. This server will store the different devices that are communicating with it. And we have also a mobile application that we will call a client that handles also its own devices. For example, for example, when I'm at home, I can have several sensors, located in different parts of at home, but I manage all of them through one mobile application. Okay, but of course, as a client, I need to communicate also with the server. So all of this is can be handled through the messaging with an intermediate broker. Okay, that allows the communication in both directions. And as you understand, I can subscribe and publish depending on where you are located. If you are a client, you will subscribe to messages that will come from the server or from the device, and you will publish on topics that are listened to by the server or by the device. Okay, so that's what I will try to show you. I hope that I will succeed. I'm not sure that all my system has my simulation is working very well. So I will change my sharing now to the screen. The first one is the device. Okay, so where is it? I will save this one. Let's save it as untitled. Never mind. Okay, I have this. This is the device. So I will stop. It's working. I will stop it. Now I will show you very quickly the different blocks. Here, when I hit the flag, the green flag, sorry, I'm painting my my scene, and you will see that I have a sensor, and I made it as a slider. Okay, we will see how it will work later on. So when I click on the green flag, so that I can initialize my client, my MQTT client, I mean, embedded in this device, I click the red dot so that it is connected. And when we get to look on the different subscriptions here, we subscribe the client to a first topic that is called the server, to communicate with the server. I subscribe it to a user ID. So this will be my user ID when I'm connected to my mobile application, for example. And of course, I'm subscribing to my own device ID so that I can listen to any information that may come from this device ID. Again, and I will publish also my device ID to the client, to the server, sorry, and also to the mobile application. So when I publish this device ID, this will notify the server and will notify the mobile application that the device is connected, okay, and is communicating some information. So it is stored as connected, okay. And of course, I have here my topics and messaging. Now, the only thing that two things I have handled here, say, is when I receive a message that is ping, so the server is pinging me, for example, I need to answer him, and I publish my device ID again, so the server can be notified that I'm connected. Okay, and now let's go to my sensor. The sensor is working in a way that when I click here on the gray dot here, I can slide it up and down so that I can simulate as if I am a thermometer and I'm giving a temperature that should be then captured by the server or by the mobile application. For example, it's 33, 34 degrees Celsius. Here in France, we are in Celsius degrees. We work with Celsius degrees, sorry. So, and when I click again, I will fix this temperature, and you see here I will publish my temperature, and it is sent. When it is sent, it should be captured by my client. Okay, so I think that this is the device part. Let's go now to the server. I will stop it from working now first. I'll repeat everything. So I will initialize everything. I have here the list of my connected devices to the server and also the list of my connected clients. I'm not sure that I have well implemented the clients part, but the devices part is working very well. Okay. Again, here I have my device that is connected. Okay, so it's a green. I will keep it green for now. Now, as you see, it is not stopped. Okay. I will stop everything and we'll reinitialize. Okay. Now let's connect the server. When it is connected, the first time it is connected, it will send a ping, and we will see in few moments the device that should answer this ping. I'll change the view here, table view. Okay. Okay, we got it. So our device is connected. So here it's disconnected by the system that I implemented here, so that I need to refresh the status from time to time to be sure that my device is well connected. So you see that communication here is working almost alone. I'm just executing the code, and the different screens are communicating together between, so the communication between the server and the device is going very well. And here we need to wait a little bit so that you can consume the ping answer. Come on. Yes, so it's very quickly. So I will put 10 here so that it can stay more. So it's actually connected, in fact, because it's well pinging, but here we don't see it. It's not refreshing very well. Maybe it's an issue with my code, but the communication is well done. Okay. Now let's go to my client part, and I haven't implemented this temperature thing. So what I will do, I will add a variable here in which I will put temperature, and this will help me log the temperature that I'm receiving from my device. Okay, so again, my device, when it publishes the temperature, it publishes it on its device ID. Okay, so here I need to check when I got the message. Let's see for each item of my device list. I will call it device. I need to get if the message, or if the topic, sorry, is equal to, so the device here, we have 3 parts. I need to take the first item of device. Then I will log the received message as the received temperature. Okay, now let's connect my client. I initialize everything. I click on the green dot here. I wait until my device is notified as connected. Sometimes it needs some refresh. Oh, I have it here. Yes, it's connected. I see it now here. And then I will change the temperature here. So I will put 50, for example, 51. Okay. So now it is sent, I'm sure. I go to my client and let's check my temperature, it's still 0. So I will repeat again. So my device is a device ID, which is a device ABCDEF. Is it ABCDEF01? Okay. Let's change the temperature again. So the temperature is not well. There is a message that is sent, but I'm sorry, I'm debugging in real time with you. So I hope that you have got the point, but it's not working very well. So for each device, set the temperature as the message that is received from the device. I'm sorry, it's not working. There is something that I'm missing, but I hope that you got the point. Maybe if you can help me, if you have any ideas. So I will make my blocks a little bigger so that you can follow with me. So when I got the message, I will make a check instead of making for each device. I will put an if control. I'm sorry. If my topic is equal to this device ABCDEF01. Okay, so I'm receiving some messages. I will read you what they are showing me. No, it's not working. I don't know why it's not. Maybe I'm not subscribing. Oh, yes, I see. This is the point. Because I'm not subscribing to the correct device. So that's why it wasn't working. Because I was subscribed. I need each time I receive a new device, I should subscribe to it immediately. And I haven't implemented it. And this was my error. But I will repeat by directly connecting to my device, since I know it's device ID. Okay, and then I will repeat everything. Okay, I hit here again, and then let's change the temperature. And this time, of course, it will be triggered correctly. And we have temperature here 19. So this was my error. In fact, in my code here, some part when I ping it, when I make the ping, I need to, and when I receive, each time I have a notification of a new connected device, I need to subscribe to its topic so that I can receive its messages. And this was the point that I was missing. Okay, so thank you very much. I have finished. So if you have any question, I will be glad to answer.
Just like to say it was very good. Thank you very much.
Thank you. Okay. So we'll continue sharing my screen maybe. So enjoy the use of this Mqtt library. I would be more than happy to help in if any need. Okay, you have all my contacts on my Snap forum profile. Okay, thank you very much.